have really kind of breaks down some of the most important things that we are going to use throughout proofs. Do you have one of these already? And it's going to be something that you can use not only in this chapter, but in future chapters where we come across proofs.
Do you have an extra notes packet? I can't find mine.
I don't have an extra notes packet, actually. I have run out of extra notes packets. So,
Oh, I got it.
people losing them. Perfect. Okay. So, keeping a hold of this sheet is going to be something that I highly recommend that will help moving forward. So making sure that your name is on it, so I know who to return it to if it gets left here. Because this sheet holds the properties that we come across in proofs. Some of these properties we've already seen, like the addition property of equality. When we come across the addition property of equality, do you remember what I said you could just write on the side with the proof? Instead of writing the entire addition property of equality? We could just write add, ADD. What about subtraction property of equality? SUBT. Multiplication. Multiplication. MULT. Division. Div. Distribute. Dist. Simplify. Simp. And those are the ones that we've talked about so far. Open up your notes back to page 14, and we're going to be adding some more, including some that we're going to add directly onto our sheet. Dalton, do you have this sheet, or do you need a new one? Come on, do you have this sheet?
Stop, bro. 6 feet away. I don't know how to time to get 6.
Okay. Okay, page 14 of our notes back. Okay, lots of side conversations going on. I need focus up here. So, today, some of the ones that we come across in our notes packet that you're going to see today focus in on the reflexive property, which is both on your orange sheet and on your notes packet. We will just use reflex. And the reflexive property says that something is equal to itself. It's a property that we don't use a whole lot in this chapter, but it's a property that gets used a lot in a future chapter. It has a purpose. You're not going to see it a whole lot here. Ooh. Substitution. We dealt with that one before. How did we shorten that one? Not just sub. Subt. With the T at the end is subtract. Substitution is SUBS. We will come across the symmetric property. SYMM. We talked about this a little bit last week because it came up in some of the problems. I did not hold the symmetric property against you if you didn't do it on the quiz, but you accidentally flipped things around. But moving forward, you have to make sure symmetric property is what allows you to flip things, to change something like 12 equals x into x equals 12. You have to make sure that in a proof that is a separate step. And the last one that we deal with is the transitive property. At least that's on this side of the sheet. We're going to deal with the other ones too. The transitive property is one of the more complicated ones. It's not too terrible once you get used to it. It just seems complicated because there's a lot to it. And the transitive property says that if you have two equations that are equal to the same thing, so, for example, with just plain algebra, it'd be like something A equals B and B equals C, therefore A equals C. It says, hey, these two things are the same, and if they're both, two things are equal to them, we can just say those two things are equal to each other. We can do it with regular equations. We can do it with segments, where two segments are equal to the same segment, or we can do it with angles, where you have two different angles equal to the same third angle. Being able to use these properties and recognize these properties is going to be a huge thing in proofs, because these properties are what you get to use as evidence for how you know certain things are true. So one of the things that you'll be asked to do is recognize what property is being used. It'll give you something like r equals t and say, okay, we've changed it to become 15r equals 15t. And the question is, what rule allowed us to make this change? What is the change that you see happened? The numbers popped up, the 15 popped up. What operation is happening between the 15 and the r and the 15 and the t? What's right here? Multiplication. So they multiplied both sides by 15. That is the multiplication property of equality that they used. B said they started with 2 in front of parentheses, 23x plus 7, and changed it into 46x plus 14. What did they do? They distributed. They used the distributive property. Okay, question C. Started with DF is equal to BE, but changed it into BE equals DF. What changed? Flip-flop the order. Symmetric. D says started with both the fact that the measure of angle LMN is equal to the measure of angle WXY, and that the measure of angle LMN is 24. Everything in the if part is what they started with. They started with two pieces of information here. And they simplified it down to this. What changed? Yeah, this one tends to trip people up a little bit. Look at the two things they knew from the beginning. Do you notice anything in common between them? They're both angles. Beautiful. Do they have the same angle in both expressions? LMN, LMN. If two things are equal to the same thing, they're equal to each other, is the transitive property. E also started with two things. It started with AB plus BC equals AC, and AB equals 12. Now there's a slight difference about this one as compared to the previous one. Do I see some things in common? Yes. These two statements have in common what? AB. Now, in the previous problem, the thing they had in common was equal to everything else. This one, well, AB is equal to 12, this side isn't an equal sign, which means it's not transitive property. Transitive needs them both to be equal to the same thing. Okay, so they weren't both equal to the same thing. But if I look a little closer at what my end result was, make sure phones are off and up here. If I look at these things, okay, we'll be dealing with that in a minute. In the meantime, we're going to continue with math. Do you notice that these ones look kind of similar?
Yeah.
It's kind of built up almost in the same structure with something plus something equals something else, and most of the things are the same. It's got AC in common, BC in common. The thing that changed was AB. AB became 12. We knew that AB was 12. They told us that. We replaced something with what it is equal to. Which property allows us to replace something with what it's equal to? Substitution. So one of the things is recognizing the property when it's used. Another thing is just simply being able to use the property, which is the second half of what shows up here. Use the property to complete the statement. The first one is the reflexive property. According to above, the reflexive property has something equal to itself. So if I have the measure of angle ABC, I'm going to finish it with the measure of angle ABC. The next one is the transitive property. Transitive property of equality starts with if LM equals MN and MN equals 48. Transitive property requires two things to be equal to the same thing. Here's my two equations. What do they have in common? What's the same between the two of them? Not both of these equal to 48. Something else in them is the exact same. Or were you answering the final question? Yes. The final question will be equal to 48 because what they have in common is MN. And transitive property says if both things are equal to MN, they're equal to each other, we can cut out the middleman. So yes, equals 48. Substitution property of equality. The measure of angle XYZ plus the measure of angle WXY is the measure of angle DEF, but we know the measure of angle DEF is 93. They have that in common. I can replace and say the measure of angle XYZ plus the measure of angle WXY is instead equal to, what's DEF actually equal to? 93. There's two more examples here, and there's one other thing we're going to be going through. Addition property of equality. If AB is equal to BC, then AB plus DE is equal to the AB stayed, the plus DE appeared. If you want to add something to one side of the equal sign, you must add it not only to one side, but to the other. which means what's on the other side of this equal sign is BC plus DE. Last one on this sheet wants to use the symmetric property. Starts with 12 is equal to x. Symmetric allows us to switch and write x is equal to 12. We're not moving on to the next page of our regular notes packet. We're going to be looking at the back of this instead. If you want to, I guess. We're not writing in it more today. Please do. Alyssa, do you have one of these extra sheets? Would you be so kind as to pass that back? So, in order to do the things that we're going to do today, we are going to want to know what all of our properties allow us to say. So that's why I've switched over to the back of this orange sheet. The back of this orange sheet, in all technicality, there are two terms that we haven't come across yet in this class, but you've done them before, so we're going to bring them back. Otherwise, most of this stuff we learned back in chapter 1, like the segment addition postulate, which within a proof I will shorten down to seg add post. And the segment addition postulate says that if I have a picture that looks like this, where there's 3 points on a segment, I can add the two smaller segments, AB plus BC, and say that that is equal to the big segment, AC. Now, one of the things that I mentioned back in chapter 1, because I wrote out a version of this quite a bit back in chapter 1, and I told you back in chapter 1, for now you don't have to write the lettery version. But eventually, you will need to. Now is eventually. In proofs, if you use the segment addition postulate, in your proof, you come up with the lettery version of the equation. And then we modify it from there. Now, in all actuality, today we're just recognizing properties. We're not actually doing the proofs. So, just trying to get there. We also had angle addition postulate back in chapter 1. Similar in idea, you can add up two small angles to make a big one. So if I've got this picture here, if I have a picture that looks like this, I can say that the measure of angle, the small one on top I start with, you can start with either small one. So measure of angle, CDI. I can add the measure of the other small angle, IDE, to get the big angle, the measure of angle CDE. Those were two postulates we dealt with quite a bit in chapter 1, and they are going to come up a decent chunk in these proofs. Because our proofs that we're going to do in this chapter rely a lot on just emphasizing the math we did back in chapter 1. These are the two terms that you just haven't necessarily seen in this class yet. Definition of supplementary, definition of complementary. You would have dealt with them in middle school, but it's been a minute. Now, in a proof, to come across stuff in this lower section, do you notice where it says in gray, things you'll get from words? In proofs, I might tell you that a couple of angles are supplementary. It'll look something like this in a proof. Angle ABC and angle XYZ are supplementary. If you come across that in a proof, we are able to write the following. That the measure of angle ABC plus the measure of angle XYZ, those things added together is equal to 180 degrees, because that's what supplementary means. It means two angles that add up to 180. Definition of complementary is very similar. If you see that two angles are complementary, we can add them up. But this time, they only equal 90. Complementary means two angles that add up to 90. Today we're just going to finish these 3 boxes. We'll get the last 4 at a later date. Definition of bisect, or more accurately, definition of segment bisect and definition of angle bisect. Make sure you're writing this here, because we actually have to write the property there. Do y'all remember what bisect means?
Where it like meets and like cuts in
It
half.
does tend to go in the middle, but it cuts in half. It cuts into 2 parts that are congruent. Now, do you notice that these ones are underlined? Underlined ones, it says up here, generally means you're going to have a picture that kind of helps you out as well. So I'm just going to draw a very, 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 very tiny version of the picture, because I have things that I need to write with this. If I come across something that looks like this, and we are told that point M bisects AB, we are able to say that AM is equal to MB. Those two halves are equal to each other. I can do the same idea with angles. Again, tiny picture. If I see the words that something is bisected, I look at one of these two. If it's an angle bisector, such as BD bisects angle ABC, then similar to this, where I could say the segments are equal, this one I can say the angles are equal. Specifically, angle ABD is equal to DBC in this picture. Don't forget the measures and the angle symbol. It's the two small parts that are equal to one another, whether it be the angles or the two small parts of the segment. Definition of midpoint looks nearly identical to a segment bisector. This one I got a little more room to draw the picture. The difference between bisect and midpoint is that a bisector isn't always a point. A midpoint is always a point. And we are able to say that the two halves are equal to one another. So, today, oh, I'm zoomed too far in. You can't see that, my bad. Today, I've got a worksheet for you. Now the worksheet is structured a little differently, so for the sake of your sanity, I'm just going to clarify the worksheet a little bit. Essentially, yay free answers. Today's worksheet is essentially broken up into 3 columns. The 3 columns represent what you were given to begin with, what it changed into, and what property you used to get there. So we did this in our notes, but we did it in a slightly different structure, so I just want to make sure that we're 100% clear on what we're doing. The first column is what you start with, the second column is what it changed into. The third column is the property. If I started with AM equals MB and it changed into AM plus 5 equals MB plus 5, what is the change that you see happened? Add 5. What property says we can add 5 to both sides? Addition, property of equality, add. That's what I'm looking for. If it's looking for this one here, it's saying what would the problem have originally been? If we were using the multiplication property of equality and we got something that says 3x equals 3y, what did we probably start with? X equals y. Because they both got multiplied by 3. A little more complicated, if you look at the back, we're going to do one of those ones too. We're going to take a look at the one on top. The one on top says we're given this picture, and we're going to use the segment addition postulate. Segment addition postulate says that if we see a picture like that, we can write this statement. But we have to do it with these letters. So instead of AB, what would I write? GH. Plus, instead of BC? HI. Equal to? GI. That's the type of thing we're looking for on here. Any questions? Okay. I gave you 3 of the answers. Go ahead and continue to fill in.